Hi friends, welcome back to my channel. In this video, we will discuss about Java 1.8 features or functional interfaces and Lambda expressions. These are the main and most important one of the feature in Java 8. First, we will discuss about the functional interface and then Lambda expressions, and together what we can do, and later we'll go for some hands-on coding. Okay, let's start with the functional interface. Functional interface, by definition, we can say a functional interface is an interface that has only one abstract method. It can have any number of default static methods. The reason we have default methods in interface is to allow the developers to add new methods to the interface without affecting the classes that implement these interfaces. Once write the default implementation to a particular method in an interface, there is no need to implement it in the classes that using this interface, which means the implementing class. But it can also declare methods of object class in the functional interface. Functional interface is also known as single abstract method. In general, we can also call it as SAM interfaces, means single abstract method interfaces. Let's make a note here. It is not mandatory to use functional interface annotation. By default, if you have only one abstract method, it can be treated as a functional interface. But it's best practice to use it with functional interfaces to avoid addition of extra methods accidentally. If the interface is annotated with @functional interface annotation, and if we try to add more than one abstract method, it will throw the compilation error, right? Which means if an interface is marked with the annotation explicitly, then if user try to add any new abstract method, it will not allow the user to add that extra method. That we will show during hands-on. Java 8 has new package java.util.function that contains many functional interfaces. But there are some default functional interfaces which are coming from this package java.util.function. Those main interfaces are predicate, consumer, supplier, and function. We will discuss these interfaces in the later session. Then, functional interface can be instantiated using Lambda expression. Right? So, this is all about the definition and the rules of the functional interfaces. Coming to that, next, Lambda expression. What is a Lambda expression? Generally, we think that if you go to some other programming languages such as C, C++, JavaScript, they are called functional programming language because we can write functions and use them when required. Some of these languages support object-oriented programming as well as functional programming. Lambda expression is the feature which made the functional programming possible in Java. Prior to 1.8, Java is pure object-oriented programming. With the help of functional interface and Lambda expressions, we can achieve the functional programming in Java. It is mainly to implement functional interface to support functional programming. Means Lambda expression is tightly wired with functional interfaces. We can create instance of a functional interface using this Lambda expression only, rather than using anonymous class. One of the clear benefit of using lambda expression is that the amount of code is reduced. The lambda expressions are easy and contains three parts like the parameters, arrow mark and expression. Expression is nothing but the method body which you are going to provide. Here sometimes the interview question they will ask like, can a functional interface extend another functional interface? It is a confusion for some of the developers. We can say yes. When do you say yes? If that one of the functional interface does not have any abstract method, then we can extend another functional interface, because by extending that functional interface you still have only one abstract method. You can say no. When we have an abstract method in both the functional interfaces, it is not possible. By doing that, if you try to extend another functional interface which have already abstract method, then totally you will get two abstract method, which violation of functional interface definition, right? Functional interface can extend another interfaces only when it does not have an abstract method. Please remember this one. Also, you cannot override the default method of an interface from the implementation class. So these are the main and commonly used interview questions. Then next we'll move on some hands-on. As told you that a functional interface, how we create a functional interface, first we'll go that create interface called my interface. Now my interface is right. Now what is the first tool? Functional interface having only one abstract method, right? What is that abstract method? This one abstract method. We are saying by default only one abstract method. Here we no need to write public abstract like this. By default the compiler will automatically assign this to us, which means by default all the methods in the interface are public abstract. So writing this is redundant. So this is not necessary to write here. Let's see how to implement this functional interface. Now, in general, how we do to implement this? What we do to implement the interface? We are using the keyword implements functional interface like this, right? Then a compilation error will come. It says forcefully to implement the unimplemented, to implement those methods declared in the interface, right? So this is how we are doing prior to Java 1.8. Now the context here is we are working with the functional interfaces. So here to implement the functional interface we no need to write all this implement interface and method and all. As we know, this Lambda expression is anonymous class, which means it does not have any method name, return type, any access modifier. Let's see, this make a call is one of the method that is declared in the interface. How do we write this using Lambda expression? Just see, as told you, this curly braces means parameters, then arrow mark and the expression which is a body. Here this is return type is string, So here we are not passing any argument, so no arguments are expected. Now this lambda expression you apply here, means change our method into lambda expression. See here, provide, now what is method? It is returning something. Oh, this is belongs to some interface. Which interface? My interface. Remove this and put it here. Right, for this public main method. See, my interface, create an object to our interface, then you pass this lambda expression to this. See, as told you earlier, we create an object to the functional interface using lambda expression. This is the syntax of the lambda expression. We have created an object. Then what we do next? Using this object, we can call the method that is declared in functional interface. What is the method? Make a call. Dot make a call. Now our implementation class is done. Means we have implemented a functional interface successfully. Now print this in using system. See the output. This is the method that is declared in the function interface. Using lambda expression, we have created an object. Using the interface object, we are calling that methods. Coming to this functional interface rule, as told you earlier, if you have more than one abstract method, the compilation error will come. First thing, also, it is not possible if we have more than one abstract method. Think here, see, train. Subscribe. You see, the method is allowed in the interface, but if you go to the implementation class, we will get a compilation error, which means lambda expression is applied to only functional interface, but here it is saying that target type of this expression must be functional interface, which means the interface which we are implemented is not a functional interface. So that is the reason it fails. So let the method be here and mark this interface with functional interface. Then you see another error. This error says that this is the functional interface. You do not have multiple abstract methods. See here, invalid functional interface annotation, which means my functional interface is not functional interface, which means as per the rule of functional interface, we do not have more than one abstract method. Remove that. See, the error is gone here and from here. As I told you, we can have default methods in the functional interface. Let's create one default method which return some string. I can say receive call. Here what we do, I am going to return call received successfully. Now just simple string we are returning. How do we call this default method? Using interface object only. Here you see this interface object dot what is your default method? Just receive call. So is successfully we can call default method also. This if want to print that using sysout, print this object. So you will get the output of from abstract method as well as the default method. Let's see. This is the abstract method that is returning, and this is the output from the default method. One more thing, as we discussed, a functional interface can have as static methods also. Static methods are nothing special in functional interface. Static methods are similar to our class static methods. We can directly call using interface object. Right? There is no special behavior for static methods do in the functional interfaces. Just try with one static method. Now I am not going to return anything. I just printing. This is static method. Sorry, have to use a static keyword. Now, as told you, we can directly call from interface class dot my static method. That's it. To print that, again use the same sysout. Sorry, this we are not returning anything. Okay, directly we can call this. See, all these three types of methods are working successfully. As per the definition, functional interface can have only one abstract method, this, and can have any number of default methods. But here I declared one default method. You can try with multiple default methods with different data types, string, double, int, log, integer. We can have any number of default methods and static methods. This is what about the functional interface and the Lambda expressions. And once again, we'll recap about the function interface and the Lambda expression. As told you, by definition, a functional interface is an interface that has exactly one method. It can have any number of default and static method, and it can be called as a SAM interface, which means single abstract method interfaces. Next thing, Lambda expression is the feature that makes the functional programming possible in Java. We can create the instance of a functional interface using Lambda expressions rather than anonymous class. All the syntax of this functional Lambda expression, see, it's with the default without parameters. This is one parameter and two parameter. If you want to see that with one parameter and two parameter, we can change the current method by accepting as one parameter string name. At the same time, when we add a parameter to the existing abstract method, in the implementation class also we have to pass the argument, right, as passing this name. Now here the make call is the one which we have changed. We are passing something, right? Just see Java. Now we can print this argument here. See, now run as Java application. See, it's comes. Similarly, we can go with multiple arguments. For example, this method we comment right now and create another method which return integer, and the method calculate with two parameters is x comma y. Now this is the calculate method. Now what we do next? This abstract method can be implemented in the function interface. Now here we have changed the method with two parameters x comma y, or you can give, it's not only to give x and y, you can give anything. Also here you no need to specify the data types that are given in the abstract method. By default, this lambda expression automatically identifies what data types you have given. Now see here, you pass those input here 10 comma 20, and what we are returning here, again we are returning the integer, not the string. What we do, let's return type x plus y is the output. The make call is removed and changed to as calculate. Now see, 10 plus 20 is result is 30. This way we can use lambda expression with different number of parameters and with no parameters. Hope you are clear this lambda expression and functional interface. In simple terms, we can say using lambda expressions and functional interface we can achieve functional programming in Java, and we can instantiate the object using lambda expressions. Okay guys, friends, thank you for watching my tutorial. And the next coming video we will discuss about the default functional interfaces and the main functional interfaces before we move to the stream APIs. Those are the new and important functional interfaces that are coming very frequently in our stream APIs. Thank you for now and catch you in the next video.